So good afternoon, and it is now afternoon, and welcome. Thank you for joining us for what I think will be a fascinating hour. I'm sure of that. My name is John Vincent, and I'm the CEO of the International Federation of Airworthiness, IFA. I'm standing in today for Dr. Hazel Courtney, who is our president, the president of IFA. Hazel's been called away. We're very grateful for her for linking up with Simon and organising this event. Today, I have great pleasure in interviewing Simon Stacey from Leonardo in the UK. He has a great deal of experience and notable achievements in his field, in the rotorcraft field. Our interview is focusing on, where does rotorcraft, where does vertical lift, where does it go next? Now, IFA, International Federation of Airworthiness, organizes these free events with the idea of promoting airworthiness. IFA is a charity, a UK charity, and we'd be very grateful if you'd support us. We're always looking for people to make small donations to keep us going. If you visit our website, there's a little button that you can press to make a donation, and that would help us do more things like this, more general events promoting airworthiness. As we go, you may know with Zoom, you have a chat function. So please feel free to ask any questions that you might have, any specific questions. We'll try and leave sort of 10 minutes at the end, at least, to address those questions. And the event itself is being recorded, so please be aware of that. We will, I hope, make the recording available to people. So without further ado, that's my introduction. Simon, would you like to introduce yourself?
Yes, sure. Good afternoon, everybody. And thank you for joining us on this conversation. My name is Simon Stacey, and from 1989 until 2023, I was involved in research and development here in Yeovil at what started off as Westland Helicopters and ultimately became part of the Leonardo company. And my focus through that time was heavily biased towards materials, structures, and then ultimately rotors, passive rotors, and then active rotors. And the active rotor program is the activity that led to this conversation in terms of receipt of an award.
Yeah, and I believe you have that behind you.
Yes, indeed. Here is one that I made earlier, and what I can do is just talk you through the program. So, as I say, I was very honoured, and thank you to the UK members of the Vertical Flight Society chapter for nominating, and for the award. I was awarded a Career Achievement Award, and that pertained to the Active Blade program, the RTVP program, Rotorcraft Technology Validation Program. I can still remember the acronym. And that was a very creative time for us. It was a very creative time, not just for us here in Yeovil, but for all of those people that we partnered with as well, because the history of rotorcraft development, certainly rotor development in Yeovil, has always been one of interaction. There's always been a close relationship between the company and between academic institutions and small and medium enterprise institutions. But would you like me to show you the blade? I can do a quick walk and talk as we go here.
I think a quick walk and talk would be great, because
so stand by.
I'm familiar with the design, and I think it's absolutely fascinating what you've done there.
Yeah, so let me apologize now for any induced motion sickness, because I'm going to turn the camera around and walk around. Okay.
That does make me a bit dizzy, I must admit.
Yeah, I'll move really slowly. So here is, as I say, one we made earlier. Is my audio okay?
Yeah, it's perfect.
Okay, so here is one we made earlier, and this shows you really what we're talking about. So this is this was based upon an AW139 blade It was actually a non-standard version of that blade because we needed as stiff a blade, as stiff and as light a blade as we could get, and I'll dig into why it needed to be light. But what are the obvious things that you can see? Well, the obvious things you can see are that we have patched in red here 2 active zones, 2 flap zones. So you have one on the outboard area and one on the inboard area. For those who really love their specs, you're talking about a flap that has no more than 15% chord, and a flap that has, in terms of its overall span-wise dominance, no more than about just over 20%. Note as well.
Simon, the active driving mechanisms are within the blade, contained within.
Yes. So what I'll do when I sit down is I'll pull out a section and I'll show you a little bit more of that. Notice as well, so the first audience shout out to the afternoon, the RTVP logo, again for the geeks amongst you. This blade was there to look at the 2nd and 3rd flap modes, because that is where there is so much energy tied up in a 5-bladed articulated rotor. And Malcolm Foster, to his credit, came up with this logo, which sadly sailed gracefully over the top of most people's heads, but I always liked it as a logo. I think it did us proud. So that's the blade itself. What I'll do now is just go sit down, and I'll give you a little bit more of an intro as to the technology itself, just so that you can understand why it was such a challenge.
It is unusual, isn't it? Because it's not usual to make a blade more complicated. I thought one of the maxims was to try and keep things as simple as possible.
Absolutely right, and that's a great point, really, because understanding whether making the rotor blade more complicated was a good or bad thing was really what we needed to get to flight and go and explore. Here's a sort of rapid prototype 3D version of the blade. Now, of course, in most rotor blades, for those not familiar, since the 1980s, we've made the trailing edge skin work harder than just being an aerodynamic surface. So we've put load-bearing material in there in unidirectional orientations rather than just plain wovens. And of course, what that means is the whole box is doing a job. And of course, a rotor blade balanced around the quarter chord. So if you want to have a large effect on the lag mode, for example, because all the changes you make are about controlling the vibratory behaviors of the rotor blade relative to the rest of the air vehicle. If you want to control the lag mode, the best place to put those plies is right down the back here. So we've evolved through, in the UK, through the British experimental rotor programs, BERT 3 and then BERT 4 that I ran as well, in making that passive structure absolutely perfect, as optimized as we could get it. And then we came along here and we said, well, I'll tell you what we'll do. We're going to cut the back off. We're going to destroy where you thought you were going to put the lag stiffness. And by the way, of course, we're therefore going to add weight, because if you have to move that lag stiffness further forward, then it becomes heavier. And weight further aft is not a great thing to do. Oh, well, that's fine, because in the front of the blade, we're now going to stick an actuator that weighs, I don't know, a kilo or so. So we did an immense amount of philosophical damage to anybody offended by changing passive blade design. Did it work? I'm sad to say that we got the blades all the way to flight readiness, but then COVID struck us. So of course that forced the entire industry to reassess what its priorities were. This was a research and development program that in the end was being funded internally. And it would be very difficult to justify taking that further.
So what are the performance benefits of such an arrangement?
So the small flap array that you can see on the end there was designed to move plus minus 3 degrees. And it was all about changing the local aerodynamic lift in those zones that I showed you there to address the behaviors of the 2nd and 3rd flap mode to reduce vibration. So this blade was all about vibration reduction. And of course, again, for those familiar with helicopters, either directly or just as passengers or users, helicopters vibrate a lot. So our ability to influence that vibration is important. And therefore, coming back to the question of should we have made the blade that complicated, that's really what we were there to find out, because the potential benefit of having active zones far outstrips some of the complexity that you're putting in, which is to say, there are already active ways of controlling vibration in a helicopter, and Leonardo is amongst one of a number that have some very effective systems, single point actuators or dual point actuators that you place within load paths to put anti-phase vibration in. Those systems have constraints. They sometimes struggle to follow an aircraft through a tight maneuver. They sometimes struggle to contain the vibration when you have a particular load condition a long way forward.
Involved if you've got the whole mass of the transmission system.
Well, this is the interesting thing. It is a lot of energy by the time it gets into the fuselage. Of course, when it's back up here, you can make quite a small change and have quite a large influence. Yeah. So the potential was for anything up to 90% effectiveness on that vibration reduction and across a bigger portion of the flight envelope. So in terms of would it have been a good idea? Well, of course, helicopters, because they are such a high vibration environment, you pay for that in terms of vibration-induced unscheduled maintenance. You pay for that in terms of the reliability of your systems on board. Helicopters can't, for the most part, go and ask for a bespoke radio design, for example. You get the fixed-wing design, and what you get is the fixed-wing design with a life. So your ability to say, do you know what, I'm going to much improve the vibratory response of the fuselage could have quite a big knock-on effect in terms of that unscheduled maintenance. So it might have been worth it from that perspective. Even as far as we got the program, there was a massive amount of learning that went into it. You don't normally analyze the back of a blade aerodynamically or structurally to any great extent. It's quite a benign piece of structure and you understand what's going on there. Suddenly, we had to understand that with much greater passion. Suddenly, we had to understand from an aerodynamics perspective what it would mean if the air was getting inside the section of the blade. You know, what are the differential pressures there, and will the flap still move? Will the actuator be able to push the flap? We couldn't use a conventional hinge, so we had to use a flexural hinge design, which we had to come up with.
Is it a smart actuator? I mean, is it a custom design smart actuator?
Everything there was bespoke because nothing had been made that small before.
And you could find contractors to do that kind of thing?
We did find contractors to do that. Yes, we had to, again, find mix and match. So some contractors were mainstream, if you like. Other contractors, when it came to power electronics going into the rotor head, we were working with small, medium enterprise companies to help us transform something that would be normally a desktop PC-sized box down to something that was like a box of kitchen matches so that you could fit it in the rotor head. And it was important that it had to fit in the rotor head because the communication channel from the head down to the cabin and back again would have been too slow to constantly vary the flap's behavior as it went around the rotation. So you had to build intelligence into the rotor head, which again was a radical incursion into otherwise what was a completely benign piece of structure.
Yeah. So you said in your notes to me that this getting off the technology. What did you mean by that?
Well, doing the work certainly made me reflect upon the complexity that we were building in and whether that was a good idea. Forgive me, I'm going to plug the power back in now. We've finished our walkabout because you never know, do you? You know, we've already discussed in the context of this blade, you know, should we have made it more complicated or not? Because we can all envisage the conditions under which that additional complexity, such as sand or snow or ice, might be a very negative influence. But beyond that, certainly when we take a step back and look more holistically at the pressures that are on aerospace from the green imperative, you know, should we continue to stay on that technology roundabout of trying to drive more performance out of the structure, more performance out of the blade, higher loads into the gearbox? Or should we say, do you know what, I'm going to settle with the capability I've got now, and my technology focus, my innovation focus will be on making it have less of an impact, be making it cheaper, making it more reliable. And of course, when you look into it, nothing's new, is it really? So when I looked into this problem, it became very evident that this was the sort of debate that the fixed-wing civil aviation business went through in the 1960s. So you could go from London to New York in the late 60s in 6 hours 25, something like that. And of course, you had a very high specific fuel consumption engine ×4 driving you. So you had 4 black streaks behind you all the way there. You wind that forward to today, and that journey will take you, what, an hour and a half or 2 hours longer. But the specific fuel consumption of the engine has significantly dropped down. The passenger doesn't really feel much of the impact. You sit them behind a TV screen and they watch movies, and you have changed the dynamics. You've stuck with the capability and you've said, how can I deliver that more effectively? And I think in rotorcraft terms, the most fascinating version or example of this I've found is an aircraft called the K-MAX from Kaman. The K-MAX is used a lot in the logging industry. So it's really great at picking stuff
the
up.
contra-rotating.
That's right, the intermeshing contra-rotating.
The intermesh. It was into. Yeah, I've seen the picture of the intermesh.
Yeah, it's a really neat piece of design when it comes to the rotor, because you've got an aircraft there that will never go more than about 90 knots. So of course, normally in rotorcraft we're chasing. Oh, can it be 120? Can it be 130? Can it be 150?
Well, you folks out there in Yeovil have a speed record, don't you?
Well, that's right. The K-MAX is never going to go very far, very fast. But what it's great at doing is the job it's being bought to do, which is to pick heavy stuff up. And when you look inside the K-MAX blade, and of course, Kaman aren't very keen that we look inside the K-MAX blade, but the K-MAX blade has a Sitka spruce spar, which is wrapped by carbon fiber. So you've gone back to the very earliest days of helicopter rotor blade design, which was using modified wood structures, but it's good enough for the job. And K-MAX rotor blades, for the rotors people in the forum, they'll recognize the significance of this number. They have mean flight hours on their rotor blades of 13,000, 14,000 hours. On a conventional helicopter blade, if you've gone past 3,000 or 4,000 before you've got to go into a major overhaul, you've done very well. So to me, it's a really interesting example of, okay, maybe we should think about holistically what we do, how we do it, but we'd have to bring the customers with us.
So bringing the active technology in here, I mean, are there other areas where active technology might be able to, improve? You mentioned environmental performance, and I guess even with vibration, you'd be using less energy if you've dampened the vibration or at least stopped it at source.
One of the biggest challenges that everybody would love to address would be primary flight control. So you'd have a blade that looks sort of similar to that behind me there, but instead of being plus or minus 3 degrees, it would probably be plus or minus 10 or 15. Now, of course, what's that done for you? Well, if you couple that to an advanced level of autonomy in the flight control system, the amount of control movements that would take place to perform a maneuver would come down significantly, which is to say that the pilot would be asking for a maneuver, but not directing it through sticks, if you like. But that would be really adventurous stuff, because of course, what are you doing? For this blade here, the failure modes were benign. Yes, if a flap went hard over, up or down, or floated, it would feel quite benign. If you've got a blade that has flaps big enough for primary flight control, you're big enough to go wrong real quick.
Yeah, but there might be enough advantage in doing that sort of thing, maybe on a multi-rotor system.
There could well be, because of course what you would be doing is you'd be eliminating all of the mechanical control linkage all the way down into the aircraft. Yeah. So you've got a lot of fixed controls, which are mechanical controls with rod ends that need inspecting and so forth. You've got a lot of rotating controls as well. So the potential would be there, but it would be a very exciting program.
Yeah, so there's a lot of potential there, isn't there? And a lot of this is new materials technology and miniaturization of the electronics, the control electronics.
Yeah, absolutely. So in terms of actuation, we used an electromechanical actuation, the blade behind me in the end, but we started off by looking at a piezo actuator, a novel configuration of piezo actuator, very big. Now, of course, piezos normally work at very high frequencies. We were working at really low frequencies. But it was an interesting concept, and it did offer a lot. We just couldn't get it over the line in time.
Now, I notice you've been working with academics and small and medium-sized organizations. Is the ecosystem, sufficient to do these things that you're postulating for the future?
There is a very passionate vertical flight ecosystem within the UK. The biggest challenge to keeping any ecosystem alive is keeping it fed, of course. Yeah.
With new projects. Yeah.
With new projects, with technology demonstrators. The problem with large rotorcraft, with crewed vehicles, a new design of one of those may come along only every 10, 15, 20 years plus. And these platforms then stay in service for up to 40 years. So
When you
the
say crude, you
opportunities,
mean traditional.
yes, traditional.
Like Merlin, it's been around for a long time now. Yeah.
God bless it. Yes, and hopefully it will be for a while yet, certainly for my pension's sake. So if those designs don't come around often enough, or you're not doing significant through life or midlife upgrades on those platforms, you have to ask yourself where that learning is going to come from. Technology demonstrators are a great way to do it. And working with your SME partners is vital. This program showed us that we needed to learn from other people in terms of how we do the actuation and the power systems, for example. But this is where I think we could look to uncrewed platforms. So if you've taken
you can be a bit more adventurous if you're looking at UAVs and drones.
Well, UAVs allow you to do a much quicker design iteration, don't they? Mm-hmm. So in terms of your ability to go all the way through from one end to the other of a set of design challenges, an uncrewed platform would be a path of least resistance compared to something that human on board.
I mean, there's a burst of activity in what they call AAM, isn't there? Advanced Air Mobility, electrification, basically. I mean, are those people seen as rivals or future partners, or people on the same road of innovation as you are?
Yeah, they may be seen as rivals by some, but I think we have to remember we're all drawing on the same gene pool of engineers, certainly in the United Kingdom, and I suspect is the same in every nation as well. There are very few people who have gone into the vertical flight arena, if you like, and very few people who have the right skills. So I think we should embrace the fact that we are part of that same ecosystem and work together to develop those people. The challenges come in terms of the value set that exists in a company the size of Leonardo and the value set of a company the size of a startup, for example. And there's a lot of.
You mean you've got a long legacy, a trail of history behind you.
Yeah, and legacy is an interesting word that gets thrown around with positive and negative connotations. Some of the companies that I now deal with in the uncrewed space, they originate from software companies. And therefore, when you say legacy in a software environment, it's a negative connotation. It's last year's update, and you need the next update. But of course, legacy for mainstream aerospace or for mature aerospace or the primes rather than the neo primes
means you have the lessons learned.
We understand that legacy is something that we have built up. Legacy is something that quite often, and luckily it's not something I've witnessed particularly in my career, but legacy quite often that's been written in blood that has then gone into regulations. So I think if there's one concern I have over the relationship between old primes and new primes, if you like, is that there is a relationship there, and there is not an automatic rejection, perhaps, of positions that the new companies may see adopted by the old companies when it comes to analysis. So why do I say that? A conventional rotorcraft, we pretty much understand how one's going to behave and why now. When we start to look at some of these exciting,
maybe you don't have the same rush to market, in the way that. I mean, a lot of your products are military products, aren't they?
We're about 50-50 now. So of course, being to market is important to us. But of course, the way in which we arrive at that journey is different to that which you might find in other areas. So if you've got a company that's being driven by venture capitalist funding, for example, and investors, those investors are looking for a turnaround of their investment. And as a result, the last thing they want to hear is about the lengthy development cycles that you may end up finding yourself undertaking if you go and follow that conventional path. Come back to the fact.
Do you think they're in the danger, perhaps, of maturing their product in service and the risks associated with that?
I think that's
It's a fairly
something.
controversial thing to say, I
Yeah,
guess.
well, I think that's something we need to be aware of, and I was interested to see one of the guests here is Richard Brown. So Richard Brown is somebody with whom I've got I've had a really interesting and productive relationship during my time as the chair of the rotorcraft specialist group in the Royal Aeronautical Society, because Richard has done some really interesting work on rotor downwash. Firstly, rotor downwash are conventional platforms, and that's really important when we look at how we establish heliports, how we get aircraft, helicopters in and out of hospitals, for example, driven by some very sad statistics, such as the Exeter Hospital, Derriford Hospital incident. But when it becomes really interesting is when you apply that to novel air vehicle configurations. Now, the advent of more electric, all electric, has led us to this sort of Cambrian-like explosion that aerospace probably hasn't seen since the introduction of the jet engine.
There are lots of multi-rotor designs out there, aren't there?
That's right. So where configurations before just did not make sense, they were not going to work. Now you can go back and ask yourself the question again, can I make that work? When we start to look at some of those configurations from a conventional rotor wisdom perspective, particularly with respect to rotor wake and downwash, if you have a multitude of smaller rotors, so if you start to go from a single big rotor to smaller rotors, then obviously your disk loading has gone up. And then things may start to get exciting. So some of the work that Richard's done is posing that question, particularly when it comes to conditions such as vortex ring, because in a conventional helicopter, the vortex ring is affecting your main rotor, and it is a pretty well understood
big thing.
It's a pretty well understood event and how one might counter it. When you start to think about multi-rotors, you should ask yourself the question of whether you might find, heaven forbid, half the platform being quite happy and half the platform starting to enter a vortex ring state, because of course that becomes a really exciting control problem. These platforms at the same time tend to have very high levels of autonomy in their flight control system. So how do you educate the flight control system to be ready for that event? My concern is that when I've had some conversations, it's not that it's being thrown into the too difficult to deal with basket. That would be uncharitable. But it is perhaps being considered as something that you could explore almost solely in the purview of crude flight trials, when I think really you probably want to do a lot more analysis so that your flight control system is ready for the event. You know, the last thing the aerospace industry needs is for these conditions to be flown for the first time, 5 o'clock on a Thursday.
With that in mind, Simon, I noticed the CA have published a document on that very subject very recently. And that does seem to have been causing some waves, Are the regulators, doing the right thing here? Are they, keeping up with the technology and highlighting some of these issues that need to be addressed?
I think they are, and I think in the spirit of open technical exchange within the vertical flight community, this is what we need to be addressing, because we can't get to the stage where some of these ideas are being kicked into touch in terms of analysis because perhaps they don't suit a tech investor's time frame, for example. What we don't want to happen, what the whole of the industry cannot afford to happen, is for these conditions to be entered into the first time in service. As I was going to say, 5 o'clock on a damp, rainy winter's evening over Manhattan or Knightsbridge is not the place to discover that with certain wind flows around buildings or something like that, you could.
This in a way goes back to what you were saying earlier about UAVs and accumulating hours, perhaps, in demonstrating.
Absolutely, because I love these. I love the Cambrian period. It's, for a lifelong R&D person, it is, it's what we live for, really, to do these weird things and to go back and understand and challenge the rule set. What I like about uncrewed platforms is that we could go and do some learning in quite a more controlled environment, a bit more benign, if you like. And particularly, I love the idea of the agricultural industry. There you have an industry that's used to using all manner of large and expensive mechanical devices to do its job, including rotorcraft in not so much in Europe, but certainly in the US and Japan and Australia. So you've got an industry used to spending money on large pieces of kit. And that's important because it means they've not only got how we use it sorted, but they've got the finance and the insurance and all of those sorts of things. They're usually operated in quite benign environments. So if anything untoward did occur, then at least it would be coming down on
You have a cornfield to land in, or
that's right, cornfields, not school buses or group none sort of thing. And you could rack up those hours because I'm quite sure that we can go challenge ourselves on the reliability of these systems. And as we gain more and more experience, we'll get towards that 10 to the minus 9 we're all thinking.
Okay, most of these multi-rotor designs seem to be fixed pitch blades. I mean, are they, are they missing out on all opportunity there? Again, is it advantageous to minimize complexity and, compromise on performance, or?
It's absolutely in our interest to explore how far we can go to reduce the complexity and still get the performance out of the platform. I think the challenge with fixed pitch versus variable pitch probably comes from the work I've looked at, comes at a certain threshold above which, if you want the dynamic response to maintain the controllability, you start to need a quicker response than the sum total of the inertias of the rotor and the motor can actually respond to quickly enough. Now, if you've got automated flight control systems in there, they tend to ask for smaller iterations. So that will push that threshold, but that threshold will exist. So what are we saying? Okay, so we're no longer just variable RPM fixed pitch. We might be variable RPM, we might be variable pitch. Well, variable pitch is a really mature technology. So again, we should be able to go revisit and see how we can build that into these constructions, these rotors.
So maybe a next generation, even beyond where we are today, in terms of some people's designs. Yeah.
Absolutely. Yeah.
So going back to, conventional rotorcraft, I mean, do you see your innovation here, getting into a conventional rotorcraft in the near future?
I think the program was very much a program of its time where we were able to go and make that technology exploration, with the backing of Innovate UK, with the backing of the company. I think we would have to ask ourselves again today whether that is still the exam question we feel we face. We know even only a handful of years ago, 5-6 years ago, the idea of thinking about green rotorcraft, use of green fuels, etc., etc. Nobody really wanted to have that conversation. That has changed. And that appetite, therefore, for reduced environmental impact of rotorcraft operations will continue. And therefore, that will be one of the challenges of the urban air mobility. I think.
I was going to say, AEM claims noise benefits as well. Are there potentials here for improving the noise performance?
Noise benefits is an interesting one, and I'll sort of remain on the fence on that one, in that it is easier. The biggest challenge is to do a genuine apples for apples comparison between two air vehicles with the same level of weight effectively, and how you've achieved that with the disc loading. Certainly in some conditions, multi-rotors are going to give you advantages. When you look at the noise characteristic of main tail rotor interaction on a conventional helicopter, then in some wind angles, you get quite a lot of blade interaction in a way that you might not in a multi-rotor. Against that, you might get some really unpleasant interactions depending on what your multi-rotor configurations are, because those tip wakes have got to go somewhere, and they may go into the next rotor, in which case you'll get a beat setup.
All this is very, very specialized expertise and knowledge. I mean, are there enough people out there who've got a good grounding in this, or are we flying blind,
There is, I think there's very little question that we need more engineers in the gene pool than we have today. Very little question of that. And this is why I think it comes back to the importance of the relationship between uncrewed and crewed platforms, between advanced air mobility and more conventional rotorcraft. we are all chasing the same skills from the same group of people. So I think we have to work together to understand how, firstly, we interact, not just at the university level, but back into the secondary schools, back into the primary schools, to make vertical flight an attractive career path proposition. And of course, that has to be balanced with it being an attractive industry proposition. So we have to make sure that it's respected in whichever country our observers are sat in, that rotorcraft has its place in the value set of government, because it is very easy for governments to focus in on fixed wing civil air.
Aerospace is competing with other industries as well, isn't it? You mentioned to me the automotive industry. Do you see there needs to be a better sort of interplay perhaps between aerospace and automotive?
Yes, I do, particularly as we start to look towards more electric and all electric. The automotive sector has some great learning to offer us. This was brought home to me when I started to do a little bit of work with the University of Bath and the IAPS Centre, which has been created on the Bristol and Bath Science Park. That's a facility that was initially set up to be focused on automotive propulsion. And I went along and had a conversation with them and said, look, if I think about a small platform that's going to pick up 3, 4, 5 people, the motor sizes you're talking about are the motor sizes I'm talking about. You really should expand your horizons and maybe come play with us as well. Give them their credit. They moved their focus, and now they also are very interested in what aerospace has to offer. We must embrace that. It is very easy for us as aerospace people to imagine that we are the pinnacle of design. We are not the pinnacle of design in some of these areas.
But maybe they don't have, maybe does a safety culture there translate? Or, again, do you have this kind of cultural difference, in terms of...
There are similarities and differences is what I've found. There are differences in that, of course, they can just grind gracefully to a hole by the side of the road and nobody's really going to be too upset, and in a way that we would get upset. At the same time, of course, their mass production financial focus and the reliability focus,
huge exposure, isn't it,
actually starts to get to a similar sort of place to that where we want to be. So our understanding needs to follow theirs, because they understand. We're used in rotorcraft to perhaps doing a bit of a mix and match, dare one say it. So one customer might want one engine, another customer might want another engine. One customer might want his own radio suite and sensor suite, and the other the same. And that gives us a particular approach and mindset. When we start to look at hybrid power, it is vital, and the automotive sector has taught me this, it is vital that you integrate that design from the very earliest stages. Otherwise, the losses build up as you go from the battery to DC converters, do power switching, etc., etc. And of course, the losses are in no way perfect, because they're heat you've got to get rid of, they are power you've got to find in another way, and we just cannot do it. Which is why, therefore, it is fascinating to take a bunch of aerospace people to an automotive show and have those conversations, because they turn up thinking they're not going to learn anything, and they go away
thinking quite differently. Yeah.
Yeah.
So that's the powertrain you're talking about. What about the materials technology? I mean, everything's composite. What's developing there, where perhaps there's new learning or new ways of doing business?
Again, as you say, there's a lot of focus on composites, and this morning, Composites UK sent me through an invite to their next show, which is about the use of composites in automotive. So you could think, okay, well, maybe they're going to start to learn from us. Again, we need to work with them, because we set pretty much our composite material suite, a long time ago. Okay, we iterate it now and then. But the composite material suite that was used...
a slow process of learning.
Absolutely. And the composite material suite that we used, what Westlands used in the 1970s on the Sea-King blade, those material suites or iterations of those are still in use today. So what is the automotive industry going to do? It's going to drive volume consumption, and it's going to require complete recycle reuse.
Mm-hmm. Oh, yeah.
And therefore, we have to start working with those industries now, not least to do two things. Firstly, to attract co-funding in, because any one industry will struggle to fund the work that needs to be done. But secondly, to make sure we don't do things twice. we're great at having academic institutions that face aerospace and academic institutions that face automotive, and never the twain may meet. Well, if we're working on the same problem set, government can't afford repetition, industry can't afford repetition.
Do you find that perhaps some of the academics are living in idealized ways of thinking, and then you have real productionization going on over here, and maybe the two don't connect, or do they connect?
You get a spectrum, and I always very much trigger upon academics who like to see outcomes, and there are a lot of them out there that like to see outcomes. You know, when I come back to the relationship we built in another program with the University of Bristol on electric machines, they were really focused on delivering those outcomes, to the point where they took the work that we were doing with them, and they created an entire academic course around that, because they realized that electromechanical skill mixes were what industry was going to be looking for. So I think, yes, there is always the possibility that some academics may have a very left hand of the sheet focus, if you will, on very low technology maturity stuff.
Writing erudite papers, but not necessarily thinking about how things will work out.
Maybe so. But of course, it's always worth remembering that the TRL scale begins at one. Technology readiness
it's got to begin
at one and ends at 9, and you need that the beginning of that sausage being fed. So there is a place in the overall system for those blue sky thinkers who are very abstract and are not thinking about the right hand side.
Going back to enticing and motivating young people to come into engineering, do you think there's something more that we need to do? I mean, like your project there, telling people about what's being achieved and what exciting new projects may be just over the horizon.
Yeah, dissemination is always going to be important, because otherwise people will be left in little pigeonholes working away. So I think industry has a duty to do more than it does, to be honest with you. I think
there's a communication task there,
on the communication task side of things. But again, I come back to, I really like the idea of doing technology demonstrators frequently in an environment that will allow quite a short flash to bang cycle, and therefore the uncrewed sector will allow you to explore various different things. You could look at just the structures, you could look at just the powertrain. It would be very difficult to do, I suppose, in a conventional helicopter configuration, but again, not impossible. Not impossible by any means. You have to make sure that you do it at a scale that is sufficient that you can take the learning away, because aerodynamics rules, I'm no aerodynamicist, I will declare that now, but aerodynamics rules can be quite tricky to scale. That's why you have all of these various scaling regimes that you use in wind tunnels and so forth. So if you're going to do a demonstration, you have to make sure that it was sufficient scale to challenge you. But I think that's what we need.
Simon, it's clear you see the benefit in physical hardware and making physical hardware and flying things and trying things. There's an awful lot of talk about digital twins and more simulation, particularly in certification, producing models, very complex models to prove a design through modeling. Do you see any benefits or disbenefits in that approach?
There will definitely be a benefit in adopting a digital twin approach. I think that the threat will be to make sure that you don't have an unrealistic set of expectations as to how that digital twin will contribute to you. If you're following a fairly well-trodden path in any one aspect of attribute of the vehicle, then you should be able to construct a good digital twin, and it should be reliable to give you effectively a full flight physics behavior or a system dynamic behavior of a power system, or et cetera, et cetera. Of course, the challenge with aerospace, though, as I was touching on at the start, is we tend to be reluctant to get off of that technology around about. Therefore, we tend to be...
Because you invest so much in it.
That's right. So we tend to be pushing behavior of a system more than we've done before, and therefore we don't really have good correlation evidence. Therefore, we can't really feed a digital twin. But there are different sorts of digital twin, of course, and that is worth maintaining cognizance of. Overall, you have to do the digital twin. If you're going to do it, you have to do it at the start. And you have to take everybody in the supply chain along with you. There is no point in the big industry getting themselves ready for digital twin world if their SME supply chain, is
Yeah.
still on Windows 98.
They haven't got the data.
For want of a better phrase.
You can't feed it because they haven't got the data. Yeah, you've never required them to have the data.
That's right. And that, again, is the responsibility I see of the larger companies to get the supply chain match fit, really. So if yes to digital twins, but we do have to bring everybody along with us, and we do have to acknowledge that you may not have all of the correlation evidence to start off with. Once you've done it, of course, from your perspective, you'll be thinking, well, are you going to present this to me as part of your certification evidence? To which the answer is absolutely yes.
Well, that seems to be the case in many cases.
Absolutely, because test flying is a very expensive. Very expensive business indeed. And it's not just expensive when you're doing challenging things. It is simply expensive to operate an instrumented aircraft. The number of times, and some of the audience that have worked with me, like Malcolm Foster, will recall the number of times we put an aircraft out on the pad out here, and then you wait because something won't switch on, or something won't switch off, or something won't reset. The technology, that we were flying rotors at this stage, the rotor was fine and ready to go, but instrumentation, which is necessarily a transient installation on an aircraft, it can sometimes have a bad day. And hence the use for digital twins for certification is a really interesting area that needs exploiting.
I mean, in our conversation so far, we've talked about an enormous number of things that can be done, and maybe should be done, and relationships that should be built. So that requires, quite a lot of investment, quite a lot of finance, quite a lot of people with commitment, to move in a particular direction. Do you see that's there at the moment, or do you think it, needs a bit of a push?
I think there is it is there as to a varying degree, depending on which aspect you're looking at, whether it's crewed platforms or uncrewed platforms. I think all industry realize that they are resource strapped. Can I get the people? Can I get the cash investment? Can I find the material? And therefore, certainly when I tried to do a hybrid power proposal, which Innovate UK in their infinite wisdom chose not to fund, the ability to put together a really strong team partnership was fantastic. There were some great companies, large and small, are looking for a clear articulation of a problem set that they think they can chase that will be good for them in the long term, i.e. it will be something they can sell. So I think the challenge to date, when we look at some of the internal funding mechanisms that UK government...
Do you find these partnerships, there are ready and willing partners out there, or do sometimes...
Yes, there are.
Partnerships are difficult.
The biggest challenge a prime will face when talking to a tier 1 or tier 2 or startup company is that the startup company will think, well, the big company is going to steal my IP and run away. And, not without good...
Sometimes they do.
Some do behave that badly. Luckily, I haven't heard of any particular examples in the UK, but I've no doubt there are. And certainly it is more prevalent in the US. What we need is business innovation, is the message I now pass on within my new role within Leonardo in the corporate function. We have great technologies. We need business innovation, and business innovation is how are we going to work with those people in such a way?
Connect all these things together. Yeah.
We take advantage of their agility and their ideas. We take advantage of our mass, if you like, because mass is good when it comes to either your ability to find investment or your ability to
just to keep going when things are not working out,
and to keep going when things aren't working out. Without getting completely non-airworthiness. The cost of cash to these little companies is 3 or 4 times it is what it is to a large company. So their ability to just manage monthly cash flows is quite dramatic. So this is where we can add real value. But the challenge is, and the key is, to make sure you preserve the secret sauce. The conventional business wisdom says, I'm assessing this and I might buy them. And of course, when they buy them, the founders, the secret sauce, think, well, I'm going to buy a portion and live in the south of France. And then the secret
all that knowledge goes. Yeah, yeah.
All of that knowledge goes. So the challenge is to maintain the secret sauce, not go in there with big boots and mess things up. Maintain the agility.
Wow, Simon, we're now 10 to 2. We said we'd leave for the last moments, to answer some questions, and something has just flashed up. So, yeah, I have a question, Simon. Whether he sees the challenge to establish helicopter industry coming from eVTOL and UAM, or from the larger UAS companies, now emerging, which can we do many of today's helicopter missions at a fraction of the CAPEX, OPEX, and CO2. So this is Neil.
Yes. Great point.
Niall Cadwell. Niall, I'm sorry, did I make mincemeat of your question?
No, I think that was absolutely perfect. I mean, I just reflecting what you said about the Precambrian explosion. We were at the VLN. I was there with Richard Brown last week with the UK's research community for rotorcraft.
Yes.
What I was struck with was they're all taken up with eVTOL. Of course, it's beguiling for younger engineers to study something that's at the low TRL. What I've concluded recently is that the emerging eVTOL simply cannot do helicopter missions. They can't hover for more than a few minutes. They don't have the range, the endurance, and there's lots of questions, as you've alluded to, about downwash, outwash, stability in a vortex ring state. Which translates to a weather window for operations. And so what my perspective is that many of the missions helicopters do today are about mounting sensors, inspections, hovering for long durations.
Okay.
And some of those missions can be done now by
I think a lot of people
helicopters.
So
leave time.
Yeah, so let's Simon, would you like to respond? Because I think that is a general level of concern.
You make some solid points. There can be no doubt that I go back to an earlier point, that there is a lot of learning to be taken from eVTOL. If we simply pick apart all of the mission profiles we want to perform, there may be some that could be picked up by simpler platforms more effectively. If I come back to the K-MAX and it not wanting that high speed, for example. At the award ceremony for VFS, there was a very interesting presentation done by HEMS pilot, so emergency medical pilot. And he basically rationally pointed out that it would be very difficult to have a platform of a typical HEMS helicopter size, so AW169 in my parlance, perform that mission and fit within the ground footprint that you would expect. So there are some things that having a large single rotor and the efficiencies that go with that will always find attractive. I would say, however, let's look at all of those missions, because if we take an example in Navy operations, cross-decking, it is not efficient to use a 16-ton helicopter to move pallets of baked beans to and from. You could use a simpler platform that was a lot less capable, but that was capable enough. And I think that's what we have to station up.
I mean, this brings to my mind, what about the air taxi? If you look at companies like Whisk, the air taxi market seems to be their big thing. I mean, do you think that is a real helicopter AEM competition area?
I think we have to see firstly, we have to see the cost per seat mile genuinely. I think there's always a lot of skepticism about some of the numbers that are bandied around there. But again, let's look at the footprint and then of the air vehicle. Let's look at the legs of the vehicle, because if we fit it in a regulatory framework that we have today, it is very difficult for an all battery vehicle to have a decent mission performance and still have the contingency sum as well. And everybody recognizes
electrification is not unique to multi-rotor, is it? Because there are a number of companies looking at electrifying conventional helicopters. I mean, is that something which offers opportunity?
Yeah, so again, working with the University of Bristol, Leonardo looked at all electric tail rotor, for example, on the AW139, so quite a big aircraft, 6.5, 6.8 tons, something of that order. there are some interesting, again, coming back to the Cambrian period, there are some interesting design challenges that you thought were locked that could be unlocked there. And we should never say never on that.
That's a very interesting possibility, isn't it? I guess if the power density of batteries, suddenly surges forward in some way, that would be, a benefit to both all communities. Yeah.
I would never say never on hydrogen fuel cell, which is to say that's an area that I've been watching very closely for the last few years, because they do seem to be going through an interesting cycle. Oddly enough, they are primarily focused on automotive at the moment because they do not have the bandwidth to think about aerospace as well. But that could be something that helps us go halfway between the advantages and disadvantages of energy storage, either as batteries or supercapacitors, and your ability to still rely on a fuel, a fuel source of some form.
Right. Now, I'm open to, we've got a couple of minutes left. If there are, questions somebody would like to flash up. I think we've covered a very wide area in innovation that's going on at the moment. As you say, it's an exciting time, to be a young engineer, all these potential challenges to get involved in. But getting the knowledge that's in old heads into new heads.
Absolutely.
What can we do more on that front?
Yes, and coming back to the digital side of things, we need to challenge those old heads to make sure we understand all the processes that take place. So we need to start to train systems, and some of what I could show you around here, for example, is a way in which you can use what's technology such as digital smart benches, so that the bench starts to do the learning for you. So you use the old head to train the bench, and that bench can then train other people. But I come back to the fact that I think industry, incentivized by government, must do more to incentivize young people to come into the industry, and a diverse range of young people as well, please. Diversity is the important thing for genuine creativity.
I feel IFA and we're together in that one. I mean, that is genuinely something where we think we need to do a lot more, particularly with all the competing opportunities there are, for talented young people out there at the moment. The glamour, perhaps, of aviation isn't what it might have been in the past, and now we need to re-excite people with these new technical challenges, which offer immense opportunities, I think, in the future.
Yes, and we just need to make sure. One of my biggest gripes, I guess, is that we've had regulatory frameworks for so long that we've understood the what, but perhaps not the why. Now, in rotorcraft, that tends to happen less because we're always pushing the boundaries, because it's such a challenging set of requirements. I think we need to do more of that to make sure that when we want to open up new avenues, new airways, for example, I'm sat in the IAERA Centre here in Yeovil, we want to set up an air corridor between here and Exeter. We need to make sure that we aren't overly conservative and constraining, such that innovation could take place. We'll never drive risk to zero, regardless of the opinions of the 24/7 news cycle. But we're smart enough to understand what is acceptable, I think.
Yeah, I think we're in agreement there. Well, Simon, I think we do need to sum up now. I mean, are there any closing remarks that you'd like to make? Or a message you'd like to leave people with?
Yes, no, thank you. I've enjoyed that. When I was first invited by Hazel, her question was, when I said, well, they've asked if I'd like to talk for a while, my wife simply said, have they met you? So yes, I do like to talk. What I would say is that I would really like to more broadly propagate the message that rotorcraft does drive innovation. And the one example I would leave people with is that Westlands ran the burp-3 program that concluded in 1983. In 1985, that rotor got the world speed record. But the legacy out of the burp-3 program is not the world speed record, even though it still stands today, by the way. The legacy of that is the learning that went into the gene pool of people, and that gene pool of people went elsewhere. And some of those people, there is credible evidence that some of those people went up to Filton and they established the composite wing program, a composite wing program that today makes billions in terms of revenue for Airbus and in terms of the jobs and revenues for the United Kingdom as well. So rotorcraft, because it's got such a horrible set of design challenges, is a great way of developing new ideas and bright people. So let's stop focusing quite so much on fixed wing and CO2 reduction when it comes to ATI budgets, and let's focus a little more on rotorcraft.
I think there's a really strong message there, Simon, and I think we're happy to broadcast that one. So, I mean, it's for me to thank you, I think for what has been a conversation more than an interview. And I think it's a conversation where we both learned something. We both thoroughly enjoyed talking today.
Absolutely.
Maybe a couple of West Countrymen, talking comes naturally.
My parting point to you, the design team was located in that shed.
Oh, yeah, right.
John, if just before you release Simon, I just sent a question. Maybe due to time, you could probably just send us a feedback.
Gerard, could you just quickly reel through that, because it's easy.
Yeah, so just a quick one. I just wanted to know from Simon. I mean, this is just a wonderful presentation, and I would a quick note. Is there a way that students, or particularly learning institutions that are interested in helicopter technology, would leverage on what you're doing? I'm asking this with the background of that there are places where now helicopter training is basically knowledge has got dead completely. Matter of fact, there is my neighboring country that has cancelled helicopter operating licenses on the whole country because of lack of oversight. Okay. How can we leverage on this?
Jared, I think we need to, because I notice some people are moving off now because, the hour. Perhaps we could have this as a private conversation.
Yeah. No worries.
So I'll formally close the session today. But for those of you who want to stay and take up and discuss this subject, I think we've got the time, haven't we? Simon, have you got the time?
Yes, we've got a few minutes. I'll be honest, you've kept my mind beautifully off the fact that I have a 3 o'clock appointment at the dentist. So thank you very much for that.
We'll formally end the session, but we'll carry on with Jared's question because I think that there's an awful lot to be gained there. So thank you, everybody, for attending today. I can see from the messages that are coming through on the chat that everybody really thoroughly enjoyed, this event. We've recorded the event, so I'm hoping that we can make it generally available through the IFA website so that people can come back to it and we can point to it for others to watch and listen. So thank you, Simon. We'll formally bring the session to a close, but we'll also carry on, with this discussion about education in particular. So thank you, everybody.
Have a good afternoon, everyone.
Okay, let's continue.
Thank you.
Jared, Simon.
Sorry, yes, you're going to have to repeat the question unless I can pull the question up in the chat. Oh, there's the chat there.
Yeah, so basically, I'm just looking at how training institutions can leverage on what you're doing to nations that are not technically doing well in helicopter industry now. Anything we could perhaps advise on, or come up with
really
that would support?
Interesting question. That's a really interesting question.
And Jared, you ought to say something about your background as well. The country you're in.
Yeah. I said, I have one of my neighboring country that recently, it's now official. They've sent an official suspension letter for all helicopter operators AOC. So in the whole of Tanzania now, helicopters that are Tanzania registered cannot fly. Why? The CAA lacks oversight. And that really is not good for the industry.
Yeah. It's a really interesting question and not one I thought of before. My initial thought is whether we could encourage because what we need is a pathway, a route, don't we, for this to happen. And I wonder whether that pathway is through tie-ups between academic institutions or between airworthiness authorities or aviation authorities, or both, perhaps. Mm-hmm. Because I guess academic institutions do quite often have international linkages, but how diverse are those linkages? and therefore maybe it has to start through a sort of almost a sort of ICAO type route of needing to encourage that dissemination across nations. It's a really interesting question.
It is, because you can imagine if there was money available that you could get a secondment arranged or something. A country could second somebody, to work with Leonardo for a while, and take that expertise back and therefore fulfill the role that,
Let's not forget as well that doing what we're doing now is very effective, i.e. remote learning, remote mentoring, whatever, we've got enough technology to make it work. What we lack is the framework or the incentive that's driving it. That's really interesting.
I noticed that Emma is on board from the Aeronautical Society.
I was going to say,
perhaps this is a role for the Aeronautical Society.
This could well be something that the learned societies could contribute to.
The learned societies could make a contribution here.
Yeah, well, because the learned societies are always interested in their international footprint, and they're always interested in continually proving that we are learned societies, which of course the Aeronautical Society is. But that's what we need, isn't it? We need a framework, and we need groups that are incentivized to make it happen.
Yeah. Okay. Yeah. I think that's a good point to think on anyway. And pull whatever levers we have available to us.
Yeah. And certainly I'm happy to take that back to the rotorcraft specialist group within Aeronautical Society, which I still maintain links on. Richard Brown, who's left, is the incoming chair, for example. So I think let's not let the conversation stop here. Let's put it that way.
Okay.
Thank you. It's good. Thank you.
Well, thank you everybody again.
I think Niall's lining himself up for another question.
Niall, okay.
Well, I was only going to follow up by saying, unmanned aerial systems. So once they can lift, let's say, helicopter grade sensors, and they have a helicopter grade hover endurance, and of course the advantage of no human lives, much lower OPEX and so on. Do you see a prospect for them taking over, eating into the helicopter industry? And if they do you think multicopter actually is a reasonable concept, being mechanically simple and which gets around some of the complexities of variable pitch blades, etc. We have a 2.2 meter blade in our UAV, and you talked about noise. In fact, it's a multicopter. You talked about noise and scaling, and we've got a very stable and responsive multicopter with 2.2 meter blades, which can lift about 600, maximum takeoff 600 kg. So the multicopter seems, well, we're proving now that it can get into the realms of something that can lift, serious payloads and have serious endurance with an aircraft engine. And
is this flowcopter?
That's the flowcopter, yes. And what I was lining myself up to is, would you like to come and see it in Edinburgh? Because we're doing demonstrations this month. We've got a number of prime OEMs, end users, government agencies have been and are lined up. And if you'd like to witness and particularly hear the sound of a 2.2 meter multicopter and see it fly in loiter mode near Edinburgh, East Fortune, then you were warmly invited to come.
Oddly enough, I must come up and visit my colleagues up in Edinburgh. So I'm now sort of corporate, if you like. So I look across the three divisions.
Right.
Several of my colleagues are based in Edinburgh, so the electronics division in Edinburgh. We've currently got a program underway which really doesn't need me to come up. So I shall bear that in mind separately. There will be a redefinition of the boundaries of what platforms do what. One of the things we're working on very hard is lower cost, lower size, weight, power sensors. At the moment, you know what we make. You know what we make at the moment, and of course, you know the message. Therefore, I'm delivering into the factory in Edinburgh is this has to cost a tenth or a hundredth of what it costs at the moment. but then you can sell thousands. So yes, there will be a redistribution, and yes, there is a place for simple multicopters. Interesting that you mentioned the 600 kilo figure. So I have a completely uncorrelated theory that somewhere between 600 and 1,000 kilos, it's impossible not to start to get more complicated than you'd really like, either in terms of the rotor hub design, or because you start to run into those horrible real world problems like ice buildup or sand erosion, or all of those sorts of things. So I think you're probably sat at the upper end of that, or the lower part of that threshold. It's an interesting number. At the moment, I'm starting from first principles, and I'm doing a lot of work seeing how I can mix rotorcraft and uncrewed fixed wings, small uncrewed fixed wings. Because if you really want cheap endurance, fixed wing is a great way of doing it. As you say, you've really got to want something that's going to hover, to have a hovering platform.
Yeah. And you've got, and I suppose within the Leonardo company, you have these sensors you've alluded to, yes, which tend to be focused on the helicopter as the carrying platform. And therefore they have capability expands to fit that platform. But we now have the emergence of, for instance, electronically steered arrays at a much smaller scale. And in fact, the Osprey, of course, is an example of that, but there are even smaller ones. So that's what we've experimented with, is mounting those type of radars and using the advantage of the multicopter platform to hover for hours in one spot. And yeah, so to me, for Leonardo, there's a real opportunity to deploy some of those sensors in a much lower cost platform. Absolutely. And deliver capability to the Navy, and for instance
and that, oddly enough, is my personal mission. Yeah. So my personal mission is looking at how we can pivot the business to move towards applications that are using much lower cost platforms or mass effects or whatever you want to call them. So beginning from the point of view of, okay, our core skills are there, as you know, you're very familiar with the core skills that are in our Edinburgh site. We have to reapply those to appropriate size, weight, power, and cost sensors so that you can still deliver 60% of the benefit at 20% of the price and weight, and power consumption. Power consumption, most importantly, as well.
Yeah. Well, hopefully at some point we'll be able to show you what we have, and there could be some collaboration on the
absolutely on yeah, it's very much a two-way watch this space, because I do want us to build up our portfolio of those. Yeah.
And you have a small company, a collaboration scheme now, I see, by which Leonardo is developing relationships with AI as the first one. But yeah, I think this will be extremely helpful for your mission to do with the small sensors as well, because there's so much innovation out there with small businesses.
All I can say, because I still haven't got my permissions lined up and I constantly get told off by our comms people, all I can say is watch this space, which is to say we are engaged in a very interesting program this year that involves those SMEs, that touches on our ability to pull together all the bits we've been working on, how we work with SMEs, how can we come up with more effective size, weight, power sensors, how we work with AI on things like target recognition and so forth. Yeah. So yeah, watch this space.
Okay. Well, I think that was an interesting exchange. You're obviously seeing the potential for new ways of working in the future there. Anyway, as IFA, we are a charity. So if you feel generously inclined to make a tiny, even a small contribution to our continued existence, and we'd be very much appreciative of that.
I should give that a boost through LinkedIn as well, because we seem to have got a lot of attention there.
We try and keep the profile up. If you look at Flight Safety Foundation, for example, they're mostly speaking on the operations side or the ATM side. Engineering really doesn't get the profile that it deserves. So, we still sit as IFA on the ICAO Airworthiness panel. So we have some influence there. But I'm trying to keep the name, the profile up as much as I can.
You ever come across people like Jim Lyons?
Oh yeah. Well, I worked with him, a long time ago.
So Jim,
if it's the Jim I'm thinking of,
yes, Jim has forever been on
He's on the rotorcraft, yeah.
On the rotorcraft for, you know, talk about an anchor. I don't know where the guy found his energy from, really.
No, he must be, he's not young anymore, is he?
He's not, bless him. No, he's not. Lovely individual.
Yeah. Anyway, so IFA's job basically promote airworthiness, lift the profile of these subject areas, engineering in general. So yeah, if we can do things to help you, great, you know, and please think of us, you know, when you dip into your pocket for a few pennies, you know.
It's interesting, isn't it? You know, coming back to my point of people understanding the what they must do in terms of regulatory compliance, but not the why. And the fact that I truly, you know, every time I've met this, when you dig into the why, it's really interesting. You know, why are we asking for this margin on this component, et cetera, et cetera, et cetera. You know, that's when you start to genuinely understand what you're designing. So
yeah, well, I've always used, you know, those 6 serving men of is it Ruskin? I think, you know, who, what, where, when, why, how. Always think of those 6. Yeah.
Yeah.
I think it was Ruskin. Yeah, one of those. Yeah, 6 serving men. Anyway.
Yeah.
They shouldn't be calling them men, really. 6 serving persons. Who, what, where, when, why, and how.
Yes. Well, you know, I should be doing my small bit tomorrow because the blade stays uncovered. Because tomorrow we've got a school tour coming in for the morning.
Oh.
So I'm giving them my evolution of helicopter rotor blade as a function of materials. Taunton.
Taunton. Okay.
Yeah.
Yeah. Okay.
There we go.
Thank you very much, everyone. Thank you very much, Simon. And it was a delight. Actually, it was a pleasure. So I think this is one of the easier jobs I've had.
But did Hazel explain how we knew each other?
No, she didn't. Except, I mean, I know, or you know, spent her time at Yeovil as well. So.
Hazel was my second training placement when I joined. She was my second boss, if.
I didn't know that.
And she was in what was advanced engineering. And I got to talking to the mechanic. So she was on the sort of electrical side, if you like, of the department. It had an electrical half and a mechanical half. And I got talking to the mechanical half. I ended up getting a job in the mechanical half, and that was that.
Well, I was, as you know, in what was called then crew station integration. And I was responsible for putting the EIS in the first EH101, the prototypes. But I got that job because, of course, I came from Smith's Industries up in Cheltenham building electronic displays. So electronic display design was my, you know.
And that's, you know, you look back to what we were doing in the early 90s in terms of the...
Oh, yeah, now those huge, great cathode ray tubes, you know.
But my point is,
changed dramatically.
But we were highly focused on human factors.
Oh yeah, yeah.
In a way that I would say that I don't think we are now.
We were. I mean, I would fly the simulator lunchtime, which was an occasion when I realised that I made, you know, perhaps a good engineer, but an absolutely lousy pilot. so I'm glad I didn't choose that profession.
Yeah. But yes, the design team was in the first shed when you came out the back of the toilets.
But as I used to say when I was working with the flight test people, I said, I'll look at the systems from the inside out. You can look at the systems from the outside in. And if we put the 2 bits of information together, we'll actually understand what's going on.
We should be close, yeah.
I did that at CA as well, you know, on aircraft certification. So
fascinating. Yeah.
Working with flight tests was great fun. But yeah, I didn't necessarily enjoy the flying very much. You know, I left that to the FTEs, you know, flight test engineers, you know. Yeah, in fact, one of the things when one of the first jobs I got when I moved to CA from Westlands was the certification of the Super Mark II.
Okay.
Because at that time, Bristow's were the customer for the aircraft for the North Sea. They didn't buy the aircraft in the end, but we did all the certification work.
Wow.
So doing a bit of flight test flying over the Camargue and watching those horses and things,
Super.
down there in Marignan was actually a lot of fun.
Yeah, well, if you've got to do it somewhere, then that's not a bad location.
It's a lovely part of the world, yeah.
Yeah, I was talking to one of our divisions a while back, and they said, "Okay, so where are you going to do this flight?" Because they're buying themselves a dedicated platform, a fixed wing with lots of power couplings and stuff. We fly out of either here or Corsica. Okay.
Okay, yeah. Which do you prefer? Where do you prefer the weather? Yeah. Well, we would stay up in Aix-en-Provence, which is the art faculty of Marseille University. So you can imagine what Aix in the evenings in Aix, it's a beautiful place. But yeah, those are great days, long time ago now.
Yes, the job. Okay.
Right. Thank you all, and enjoy the rest of your day.
Indeed.
Okay?
Yes.
We shall all leave now. Bye bye.
Cheers. Bye.
Thanks, guys.
Bye.